Two things. First, the average rate of change. Change in y divided by the change in x. Now, everybody started out doing the right thing, but nobody really had a clear idea of what the average rate of change was. It's a simple idea, but it's the most important idea in pre-calculus. Okay. The rest of it's just detail, at least in preparation for a calculus course, which is what pre-calculus is supposed to do. So if you have a calculus course in your future, you really want to understand rate of change as well as you can, because then you'll understand calculus much better. So if f x is 7, y equals f of 7, which, as you know, is 2, because everybody got that. So that, but what I mean is, you had all the pieces, you just didn't put them together. Okay. So I'm not going to write out details of f of 7, but we just plug 7 in here. 7 minus 8 is -1. You square -1 and multiply by 2, and surprisingly, you get 2. Okay. And then x equals 8, that was really easy. X equals 8, f of 8 is 2 times 8 minus 8. You replace the x's by 2, and you all know that. Okay, you're all good with the function notation, and that's very gratifying. So you have 8 minus 8, which most people know is 0, and when you square that, you get 0. And when you multiply that by 2, you get 0. So you get y equals f of 8 equals 0. Okay. So delta y is 0 minus 2, which is -2. You take the second value and subtract the first value, and delta x equals 8 minus 7 equals 1. The average rate equals delta y. Delta x is -2 over 1, which is -2. Okay. So all you have to know is the definition of average rate. But you also want to have a feel for average rate. But so the definition is a good start for today. Now we've talked about it in this class, maybe even in the other one, I'm not sure. Another way to depict the average rate is there's a coordinate plane. And here's y equals 8. And here's y equals 7. How is this function? When x equals 7 is 2. So you have y equals 2 here. X equals 7 here. That gives you a point. And then you have y equals 0 when x equals 8. Well, that gives you this point. Okay. Now what you do with those 2 points is you make a drawing. You start with the line directly from one point to the other. And then you draw yourself a path parallel to the x-axis and parallel to the y-axis. And I'll draw the path this way. There are 2 ways the path to be drawn. It can be drawn down and over or over and down, right? I choose over and down because it makes it a little easier to label. I was trying to label this one down here. The 7 and the 8 would get in my way. So that's the only reason I chose to do over and down. It's just a matter of much more convenient, okay? And, okay, so we have run equals 1, that's here. So that would be this part of the path, right? And then we have the rise. Is 0 minus 2 equals -2. So we go over 1, down 2, in other words. Okay. So the slope is the rise over the run. Now that's important because delta x equals 8 minus 7 equals 1. Delta y equals 0 minus 2 equals -2. So on the graph, the rise is just your delta y and the run is just your delta x. So when you do the slope, which is rise over run, turns out that that's equal might be a little hard to read. That's equal to delta y over delta x, because the rise is equal to delta y, the run is equal to delta x. And that's the average rate of change of y with respect to x on this interval. And I could even say on interval 7 to 8. Very valuable chalk. It's obviously full of diamonds, which are the hardest substance occurs naturally. And they make it almost impossible to write with this stupid piece of chalk. I don't know why they can't do a little better with the chalk, but that's as it is. I think you can read that. Okay. And you know, you put it visible on the screen. You can look at the video. Okay. So there we have it. Well, that's the main thing you need to know about average rate of change. Except, of course, you need to know what it means in a context. We talked about last time the average rate of change of your wealth with respect to time. If you're making $60 in 4 hours, okay, that'd be $15 per hour. Of course, I wanted to make more, so I said you make $300, $75 an hour. That's even better. All right, makes sense. So that's all I'm going to say today about average rate of change. If you missed the assignment, you really ought to go back and take a look at it. You're probably going to be okay with what I've seen in here today. You're going to be okay when you get to that assignment in pre-calculus. And that's kind of the bottom line. Okay. Well, then the next thing we want to talk is composite functions, and talk about that a little bit. I think that was in pre-calculus text. remember doing that? Okay. How did it get all the way over there that quickly? What was the average rate of change of its position with respect to time? It looks like it went about 8 feet in about 3/10 of a second. If you divide 8 feet by 3/10 of a second, you find that sucker was moving at about 27 feet per second, which is close to 20 miles an hour. How did it do that without making a sound? Okay. And then how quickly did you move over there to get it? Not quite that fast. I didn't feel a sonic boom or anything. Did you move? Okay. I'm glad you found it. Okay, but you'd have trouble riding if you hadn't. All right. You know, average rates of change occur all the time. You know, how fast would you have had to move to get there before it stopped? At least as fast as it was moving, right? That's about 20 miles an hour. It's hard for people to move 20 miles an hour. Most people can't move 20 miles. Well, a lot of people can't, but you know, it's 1 in 10 maybe. Take somebody really fast. Okay. People have moved as fast as over 27 miles an hour, but nobody's made 28 yet. Actually, they have not averaged 28 miles an hour over 100 meters. Okay. 27.7, 27.8. And that hasn't changed much in my life. Well, that hasn't changed much in 80% of my life. Okay. I think Bob Hayes did it back in about 1960. Then Usain Bolt came along, and him did it a little faster. Okay. Just a little bit faster, but it's still a significant faster. Nobody's beat that yet. Now you get those guys running flat out fast, they go a little, they probably get. Yeah, I'm pretty sure they get over 30 miles an hour. Can't keep that up for long. Not more than 10 seconds. That's all rates of change. It's an average rate of change. There's the instantaneous rate of change. How fast is Bob Hayes? I was saying Bob Hayes is a notoriously slow starter. He was really fast. I don't know which one was faster. You know, flat out speed. That's thick with Bob Hayes. That's instantaneous rate of change. If you could measure how fast something is going in an instant, like that pencil. That pencil started at some speed and then somehow, I don't know how, it sped up to get over that, right? So its instantaneous velocity was the maximum at some point. So if you graph its velocity versus time, it might look like this. Okay, started out there, decided to speed up, and then it slacked off. Okay. When was it moving fastest? Well, this is velocity and this is time. Moving fastest right here, right there is its maximum velocity. Right? Okay, well, that was a digression, so grateful to the pencil for giving me that. That's a pen, isn't it? Okay, well, I didn't mean to misname it. It'll run away again if I don't call it the right thing. Okay, now let's talk about composite functions, okay? And just again, there are examples. Let's just take two functions that we're kind of familiar with. You know what the graphs look like. Okay, that's your exponential function. And that's your squaring function, for instance, right? Now, F circle G is the name of a new function. The H function is the F circle G. Okay? So we can say H equals F circle G. But when we form the function, when we get the formula for the function, we're going to use this notation. Okay? So let's just do the series of substitutions. What's F of 3? What's F of A? What's F of A plus E? What's F of G? What's F of B of X? So write down kind of quickly what these are. Let me see what you're thinking. And then we'll try to really kind of nail this notation for F of G of X. Okay, so let's do this. F of 3, well, that's, you know, you place X by 3, you're going to get 3 squared. Everybody knows that. F of A, you place X by A, you're going to get A squared. F of A plus B, none of you did this, but some people are going to want to say A squared plus B squared, which isn't right. It's got to be literal. F of A plus B is A plus B squared. And that's not equal to A squared plus B squared. It's equal to A squared plus 2AB plus B squared, but that's a different thing I'm sure we're dealing with. You want to look at this, right? Okay, that's okay. But I'm going to be literal. F of G is just G squared. Okay? Because G here doesn't necessarily mean G of X. Now, F of G of X, well, still to be safe, the safest thing you could write here would be it's equal to G X squared, right? Okay? You're sure of that? I mean, you are. You know, whatever goes in here replaces X, and that's as safe as you can be. Now, if you want to risk a little bit, you say, well, wait, G of X equals 2 to the X. So that's 2 to the X squared. Now I've got every possible step. And I'm really secure with that. Okay? Like when I did F of G of X, I looked at the F of X formula and I said that's G of X squared. Okay? Okay? Then by the rules of exponents, I'll just note that that equals 2 to the 2x. Because that's like A to the B to the C is A to the B times C. So you got to be sure you have rules for exponents. All right. Okay. So that wasn't too hard, was it? And another way you could incidentally have done this, you could have said this would have been all right too. If you want to note that G of X is 2 to the X, you could say that this is F of 2 to the X, right? But then you'd be substituting 2 to the X for X here, and that could get a little confusing. But that would have to then equal, if you replace X by 2 to the X, I think you'd have to have 2 to the X squared. So you can get there this way, or you can get there this way. I think this way is a little simpler because it's just a straightforward substitution of an expression into the formula for F. And if this is a big complicated expression, it gets a little more complicated knowing that F of whatever this big expression is just this big expression squared. But if you understand that, it's okay. Just I think you're gonna be better off if you think about this. Okay. Let's try. What's F circle G of X? Well, first of all, that F circle G of X, that's a notation you're going to see, so I mention it now. The F circle G of X is just F of G of X. I remember when I took calculus, so I hadn't had pre-calculus, I had to digest all pre-calculus. I was trying to learn calculus. Okay, I got through it, but I got through it much better if I'd had pre-calculus first. Okay, and my school didn't offer pre-calculus, but it offered another course which is on the same level, which actually benefited me even more. But still, a calculus a little harder for me. Okay, so whenever I saw F circle G, I didn't know what the heck that meant. I just knew that was F of G of X. Okay, I didn't appreciate the fact that F circle G is a way of naming the new function. Okay. And I don't know when I finally started appreciating that. I think it's an advanced undergraduate course, abstract algebra or something at the time. And so, oh, that's why they did that. So I don't want you all to go through years wondering why in the world we do this. You still might. Okay. Just hopefully. Okay, so anyhow, F circle G of X, just F of G of X, you can translate it that way. I got through a whole lot of mathematics before I knew why this was equal to this. I just knew it was. Okay. So you can think F of G of X. So how do you get F of G of X? You go ahead and write out the steps. Write it out in safe steps. Just like I did. Don't make any assumptions. Just write out things as literally as you can. Okay, now a couple of things. F circle G of X is always F of G of X, right? And if F of X is X squared, then what's F of G of X? Well, same thing was up here. F of G of X is still G of X squared. That's no different than what you had up here when F of X is X squared, right? So one confusion I saw was some people want to write F of X times G of X. The parentheses are different here. The order of operations is different. Okay. So if you wanted to write F of X G of X, that would be X squared times 1 over X. Okay, so for this function down here, this is much different than this. Okay. So again, it's important to follow the order of operations. Okay. What's in the parentheses is G of X. And that's what F looks like. So you're going to replace the X with G of X just as we did here. Now, what do you get? What is G of X? So all you got to do is plug in G of X. What we're going to say is then F of G of X is G of X squared. Okay. Because this tells us to plug in g of x into the f function. Whereas if it was like this, then we would have to do this. Okay. So g of x squared is quantity 1 over x squared. Okay, you get that straight. You get no math right now. Because again, once you've seen it like this, that's going to want to stick with you. Okay. I think that'll be straight once you get into the homework assignment. Okay. Let's do another one. For sure. Let's try this one. What I did here. And okay, so we take f of x equals 1 over x, g of x equals 2 to the x. What's f of g of x? Well, first of all, that equals 1 over g of x, right? Because f of whatever is 1 over whatever. That's what this really says. If you replace x by g of x, which is what this says to do, you're going to get 1 over g of x, right? And then, of course, everybody got it. That is 1 over 2 to the x. But I really recommend you write out this intermediate step every time until you get really used to it. Okay? Then you learn to see it. Okay? And once you learn to see it, it's okay. This is a big stumbling block for people when they take calculus. The rule in first semester calculus, it's hardest for people to get, is called the chain rule. Okay? I won't write it out for you. It's pretty simple. It uses this notation. Okay? It's actually involved with rates of change. It says that the rate of change of this function is the rate of change of g of x multiplied by the rate of change function for f applied to g of x. And that's a mouthful. You don't have to worry about it. But it's all about rates of change. That's what I mentioned. Okay. So you get the idea. Now, one thing we got to look at here. Okay. Is for this function, is there any value of x that you can't use? But what are the big restrictions on domain and range? Let's review that for a second. Okay, we did it, and I think you have an assignment coming up pretty soon on domain and range. Yeah, and you can't do the square root of a negative. Now, there are other restrictions on domain and range, but that's 90 to 100% of the restrictions you're going to see in the calculus course. Can't divide by 0, can't take the square root of a negative. Okay. So x can't be 0. So if we come back to this function for a second, x can't be 0, so the domain is all the numbers from negative infinity to 0, put together with all the numbers from 0 to infinity. I think we've seen that notation. I think we used that notation when we talked about this last week. So anyhow, you're going to be seeing that. You're going to be seeing that in calculus, for calculus. Then you're going to be seeing more of it. Okay, here, what's the domain? Well, again, you can't divide by 0, right? So is there any value of x that makes 2 to the x 0? No. You could raise 2 to any power. Okay. So the x, 2 to the x can't be 0. Any number. Every time I mess with this microphone, it switches to another microphone. Okay, Zoom just did something very strange, or my camera did, and video was turned off. I'm not sure when that happened, but real quickly, just to review what we've already done. If y equals this function, we want to find the average rate of change of x of y with respect to x between x equals 7 and x equals 8. So people knew the average rate of change had to do with the change in things, change in x, change in y, and stuff like that. So everybody found the change. Everybody found the two values of f. And it's very straightforward. First of all, we start though with the average rate of change definition. It's always good to write that down. Okay. Average rate of change of y with respect to x. Write down all the words. It'll reinforce it for you as those words get really important in calculus. Open math isn't real good about using all the words. Probably trying to avoid confusion, but it's important to distinguish the average rate of change from the instantaneous rate of change. That pencil was right across the floor. Okay, pen. Sorry, I didn't mean to console it. Okay. So if x equals 7, we get y equals 2. If x equals 8, we get y equals 0. That's very straightforward. Just plug the numbers in. So delta y is 0 minus 2. Take the later minus the earlier value. You get negative 2. And delta x is 8 minus 7, because those are two values of x. And you get 1. So the average rate is delta y over delta x. And that's negative 2 over 1, which is negative 2. We can put that on the graph. We can put the 2 points in the graph. 7, 2, we go here. 0, 8, we go here. We draw a straight line here. We can draw a path from, we draw a path parallel to one axis, parallel to the other axis. Okay. So we go here, we go here. We could have gone here and here, but we did it here and here because it's going to be easier to label because and more room. Okay. So our path goes from here to here and then from here to here. Our run is 1 unit. Our rise is negative 2 units. We go down 2. So that rise is 8 minus 7, which is 1. Run is 8 minus 7, which is 1. Rise is 0 minus 2, which is negative 2. And that coincides with our delta x and our delta y. So when we calculate the slope, which is rise over run, well, the rise is delta y, the run is delta x, so the slope is identical to the average rate of change on the interval from 7 to 8. Now, that's probably on the video, so I'm just repeating it. If you're watching the video and you've understood everything, you can probably skip ahead to 3 minutes. Okay. We have f of x equals x squared, g of x equals 2 to the x, and h, which is f of g of x, which we also can call f circle g of x. We want to find f of g of x. So we start out f of 3 equals 3 squared. I just wrote these down and asked everybody to substitute. Okay. And everybody got this and this. Now, when you got down here, you wanted to substitute 2 to the x for g, assuming that g really means g of x, even though I didn't say it. But that's okay. That's exactly what you do. Okay. But if you just write f of g equals g squared, then you have the pattern. So when you see f of g of x, you want to write g of x squared. So having established the pattern here, this is what you get. And then we can replace g of x by 2 to the x. Get 2 to the x squared, 2 to 2x. Then we did f of g of x equals f of 2 to the x equals 2 to the x squared. It could also be done like this, but I kind of recommend that you do it like this, kind of following this pattern. Now, if f of x equals x squared and g of x equals 1 over x, well, you could establish a pattern with several symbols. You're still going to say f of g of x is equal to g of x squared, right? Because f of x is the same as it was here. Now, g of x is different. It's now 1 over x, so you get 1 over x squared. Then we look at the domain. Okay. We notice that x can't be 0 because you can't divide by 0. So we say x can't be 0, and we then say the domain is the interval from negative infinity to 0, union with the interval from 0 to infinity. Well, here again, we do it for f of x equals 1 over x, q of x equals 2 to the x. In this case, f of x, if we replace x by the expression g of x, this is what we get. And then we replace g of x by the expression 2 to the x, and we get 1 over 2 to the x. And I comment that 2 to the x can't ever be 0. There's no number that you can raise 2. There's no number to which you can raise 2 to get 0. Okay? So 2 to the x can't be 0, so x could be any number. So the domain of f circle g, so that's what this function is, we call it f circle g. The domain of f circle g is, can be written this way. Okay? If you write it in interval notation, or you can say all real numbers. Okay? So you can refer to the domain by the phrase all real numbers. And there are other ways you can write it. Sometimes you'll see it written like with a big emphasized R, stands for all real numbers, but that's not a notation you're going to see on this board. Okay. 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 Give you a table for f of x. I'm using the numbers you would use for a toolkit function. If you were graphing like the squaring function on the interval from -2 to 2, these would be your x values. And you, I think you're very familiar with that, but we're not doing the squaring function. We're going to say f of x is equal to 4 here, then it's equal to 6, then it's equal to 5, then it's equal to 3, then it's equal to 1, then it's equal to -1 and -4. Okay. Now, g of x We're gonna take those negatives off of that. So that -1 will be 1, that -4 will be 4. And if x equals 1, g of x is going to equal 2. If x equals 2, g of x would be 5. X equals 3, g of x is 10. If x equals 4, we get 15. Here we get 26 and 37. Now there's a pattern to this. So we could actually figure out what g of 7, 8, and 9 are, but it's not going to be relevant. So I'm just going to remove those values from my table. My question then is, what's f of g of -1? Now we no longer have a formula for f of x. We've got a table. So can you look at the table and evaluate something? Okay, now I wrote the function backwards. We want to do g of f of -1, okay? Is there something you can substitute one of the values in here? Like, can you tell me what f of -1 is? Can you show with your fingers what's f of -1? Yeah, good. Okay, so it's really easy now. We can write this as g of 6. Now, can you tell me what g of 6 is? Got a table for g of x up here, right? So it's going to be, yeah, you're going to have to flash 10 3 times, then 5 and 2, make it 37, right? Because g of 6 is 37. So it's really easy if you have tables, and if you have the right numbers in the table. If I didn't have 6 here, you just, when I ask you what g of 6 is, you just do a question mark. It's hard to do that with your fingers. You break joints and stuff. Don't, I won't ask you to do that with your fingers. Okay, so let's make a table for g of x. For g of f of x. We know, for example, that when x is -1, g of f of x is 37. So I put -1 here, 37, right? Now, what other x numbers can I evaluate this for? Now, if we're wanting to evaluate g of f of x, well, x has to go into the f function, right? So to get a value of f of x is going to have to be one of the numbers in this table, right? And for any number in this table, I can get an f of x. So I can use -2, -1, -1/2, 0, 1/2, 1, 2. Okay. So can you fill in the rest of that table? Now, some people are writing this out in detail. And then that takes a little time, but that's a really good thing to do to reinforce what's going on. Okay, so for example, if x equals -2, p of f of -2, well, f of -2 is 4, so that's 2 to 4. And now that equals 17. Okay, and it's a good idea to write that out for every one of these values. So you can associate this notation with the table and get a really clear connection. Now you can just look at it, of course, you can follow, okay, -1 gives us 6, and then 6 gives us 37, because that's what this thing is doing. Okay, so -2 gives us 4, 4 gives us 17, so you're going to get 17. And again, it's because of definition. So then if x is -1/2, f of x is 5. And if f of x is 5, we want to do g of 5, which is going to use this table and give us 26. And then the rest of the values, just to check yourself, as we're out of time, we're going to be 3. No, it's not going to be 3. I'm looking for the thing. It's going to be 3. It's going to be 10. And it's going to be 2. And it's going to be 2 again. And then it's going to be 17. Okay. Now, one other quick comment is f of x a one-to-one function. It's not one-to-one because you get 4 for 2 different values of x, right? And you get 1 for 2 different values of x, so it's not one-to-one. So, clarifying that because some people have a little bit of trouble with the one-to-one thing. I'll talk about that more in pre-calculus because I was in the pre-calculus class. Okay, very good.